Hey guys, I'm continuing with these conceptual or unusual ACT math questions that usually occur between question number 30 to 60 on the ACT math exam. I've selected these questions because many of the students that I have personally trained seem to be struggling with these questions that I've selected overall the most. And with that within mind, I want to share these with you just in case you're struggling with them too. The other reason I'm sharing this is because I'm hoping that I'm reaching young adults who don't have the means or who do not have anyone that's reliable to help them. I want to be able to reach out to these young adults and help them as they move forward going into college. It's very important to me that we reach everyone that we can. Now, with that being said, to help us achieve that goal, please hit that like button or the share button. Share it with someone that you know that needs help. And then subscribe, because that will help us develop a large channel that's reliable, so that these people can be helped. Now, with that in mind, let's not waste any more time, and let's get moving on to the first question. Okay. So the first question is an algebraic fractional expression. And it says, which of the following equations represent the vertical asymptote? To find the vertical asymptote, all you need to do is take your denominator, 2x minus 6, set it equal to 0, and solve that equation for the number that makes 2x minus 6 equal to 0. So 2x is equal to 6. X is equal to 6 divided by 2, which is going to be x equal to 3. Now, when you substitute 3 back into the denominator, you get 2 times 3 minus 6. So 2 times 3 is 6. 6 minus 6 is 0. We found the number that makes the denominator 0. When you make the denominator 0, you find the vertical asymptote. It's also called undefined as well. Now, with that in mind, let's move on. Oh, that's going to be answer choice G. Okay, vector addition. Vector addition is real easy. Just line up your I's and your J's. So we're going to take, when the vector AI plus 3J, AI plus 3J. Is added to negative 2I plus BJ. So we're adding them. When these two are added together, it results in 6I minus 6J. Okay, so for A, what value could we substitute in for A? When you add it to negative 2, you get 6. Well, 8. 8 plus a negative 2 is equal to 6. So A is 8. Now the same thing for your J values. What value can we add to 3 to get a negative 6? So a negative 9. Negative 9 plus 3 is equal to negative 6. So A is 8 and B is equal to negative 9. Which does that fall under? Answer choice E. All right, let's move on. Okay, so now we have functions. This is asking us, what is f of g of x? Well, you know f of x is equal to x squared plus 3x. And you know g of x is equal to x plus 1. All right. F of g of x. This is asking us to take g of x and substitute into each x variable of f of x. So we're going to take x plus 1. I'm going to put parentheses around it. We're going to square it, plus 3 times x plus 1. Now we have taken g of x and substituted into each x variable of f of x. That created a binomial squared. Okay, so that means x plus 1 times x plus 1. Well, x plus 1 times x plus 1, you guys all remember, you multiply binomials by FOIL. So x times x, x squared. A positive x times a positive 1 is going to be a positive x. Positive 1 times a positive x is a positive x. And then a positive 1 times a positive 1 is a positive 1. Okay, clean this up. X squared, how many x's are there? There are 2 of them. Plus 1. So now, this binomial being squared, we know is x squared plus 2x plus 1. Let's finish this off by taking our 3 and distributing it in to the parentheses. 3 times x, 3x. 3 times 1, 3. Now we've got this equation developed. Let's take all of our like terms and combine them. So x squared, a 2x and a 3x gives us a 5x. That leaves the constants 1 and 3. So 1 plus 3 gives us 4. So f of g of x is equal to x squared plus 5x plus 4. And that's going to be answer choice A. All right, next question. Okay. For all real values of x, which of the following equations is true? Okay. You've got to know a trigonomic identity, and sometimes I don't think these questions are fair to everybody, because some people don't have enough math academics in their junior high school year. You don't see these identities. Most people don't see them until they get into a pre-cal class. But you've got to memorize this, and you can use it to the best of your ability. So the identity is sine squared x plus cosine squared x equals to 1. That holds true, and we're going to use that identity to evaluate our answer choices. Our answer choices must be identical to this. Now, look at F, G, and look at F. Notice it's equal to 7. Our identity is always equal to 1, so F is gone. Look at H. It's equal to 14, so it's wrong. Look at J. It's equal to 7, so it's wrong. So these 3 are eliminated because they were not equal to 1. That leaves G and K. Now remember, the answer has to be exactly like the identity is. Sine squared x plus cosine squared x equals 1. So if you look at G, you get sine without the square. So that makes it wrong. K is going to be our answer because you get a sine squared, you get the cosine squared. And you notice your x values are the same, 7x and 7x. And what's it equal to? 1. So therefore, it checks off. That's how you can use the identity. There are other ways to use this identity. I'm not going to go into them right now because I just want to address these questions. In other videos, I'm pretty sure I've already addressed this identity and how you can use it to solve for the sine or the cosine. Next question. Okay. So given that y varies directly as the square of x, if y is equal to 20 when x is equal to 2, what is y when x is equal to 3? All right. Given that y varies directly with the square of x, there's a relationship between y and x. We're going to call that relationship k, the constant of proportionality. We have to figure what k is. We're going to take all the information that they gave us, and then we're going to substitute it in. So y is 20, and x is 2. Now we can figure out what the constant of proportionality is. 2 squared is 4, so that's 4k. Solve this for k. So that's going to be 20 divided by 4, and that's going to be 5. So the k value is 5. So our equation is actually y is equal to 5 times x squared. Now, what is y when x is 3? Well, 5 times 3 squared. 3 squared is 9. 9 times 5 is 45. So therefore, y is 45 when x is 3. And that is answer choice G. All right, let me make that G a little bit better. There you go. Let's move on. Okay, so we come to a problem with an ellipse. It's really important to make sure you understand the ellipse equation. It's really important. So fundamentally, it's x squared over a squared plus y squared over b squared is equal to 1. Now, a and b can be interchanged depending on how the ellipse is stretched out. If it's stretched out over the x-axis, the a squared stays with the x. If it's stretched out over the y-axis, the a squared and the b squared interchange. Okay, let me get a different colored pen. I'm going to mark on the figure. Now the question says the large circle has the equation x squared plus y squared is equal to 25. So x squared plus y squared is equal to 25. Now, what is 25? That's the radius squared. So that's actually x squared plus y squared is equal to r squared. So the radius here is 5. Now that's for the large circle. So I'm going to put an arrow to that. Now the small circle, they say the equation is x squared plus y squared is equal to 4. So therefore the radius is 2. All right. Now it says, the small circle has an equation x squared plus y squared equal to 4 and intersects the ellipse at exactly 2 points. Okay, there's some more things you need to know. Very important points. The ellipse is stretched out around the x-axis. So let me show you these points. This point right here we call A. This point right here we call negative A. The ellipse is elongated around the x-axis. If it was elongated around the y-axis, we would still call those A and negative A. Now the width of the ellipse occurs right here with the y-axis. That's B. And then down here, it's going to be a negative B. Okay. Let's take what we've got here and put into our formula. Now we know the radius for the large circle is 5. And therefore that intersects the ellipse at point A. So A is 5 squared. Now, the ellipse intersects the small circle at a radius here of 2. So therefore, B is 2 squared. Let's rewrite the equation, get it cleaned up. X squared over 5 squared is 25. And then y squared over 2 squared is 4. Okay, now we've cleaned up the equation. That's going to give us answer choice D, as in dog. All right, let's move on. Oh, yeah, an integer is abundant. All right, I don't like this question because it's just difficult for you guys to really understand. An integer, a number, it is abundant if it's positive integer factors. So if the number's factors, excluding that number, have a sum that is greater than the integer, how many of the integers of 6, 8, 10, and 12 are abundant? Okay, let's take each one of them step by step. So integer 6, we need to talk about its factors. So 6 can be 1 times 6, or it can be 2 times 3. Now we have to exclude the 6. And we can sum up all of its factors, except for 6, because we have to exclude it. So 3 plus 2 is 5 plus 1. That's going to be equal to 6. Now, 6 is equal to 6, right? So 6 isn't greater than 6. So 6 doesn't work. Let's go to 8. The factors of 8 are 1 and 8, and then 2 and 4. We can't use 8, but we can use the remaining factors. 4 and 2 is 6, and 1 is 7. Now, is 7 greater than 8? No, it's not. So we can't use it. Okay, let's go to 10. Now with 10, we can have factors 1 and 10, and then 2 and 5. We can't use 10. We can use factors 1, 2, and 5. So 5 and 2 is 7 plus 1 is 8. Is 8 greater than 10? No, it's not. So we can't use 10. Let's go to 12. Now, it has factors of 1 and 12, and it can have 2 and 6, and then it can have 3 and 4. Now, we can't use 12, but we can use all the other factors. So 6 and 4 is 10, 13 plus another 2 is 15, and 1 is 16. Now, is 16 greater than 12? It is. So therefore, 12, its factors have a sum that's greater than itself. So the answer is, how many of the integers out of 6, 8, 10, and 12 are abundant? There's only one, 12. So answer choice B as in boy. All right, let's move on. We just got a couple of more and we're done. Okay. This is a neat problem. So for all values of x greater than 0, has to be greater than 0, which of the following expressions is not equivalent to this interesting root? So what we have is this. We have x squared, the cube root of x squared. But we're going to take the square root of all that. We need to simplify this. So if we're going to simplify this, we need to get rid of the radical, the square root. So we're going to do this. We're going to square the radical, cancel the radical. And then that's going to leave us the cube root of x squared. Now we can rewrite this as an exponential. And when you rewrite it as an exponential, you write it as x raised to the 2/3 power. Okay, now look at your answer choices. Which one fits that? K. Next problem. Tamika calculates that she needs 360 square feet. So 360 feet squared of new carpet. But the type of carpet that she wants is priced by the square yard. How many square yards of carpet does she need? Well, you need to know the conversion factor, and I'm going to put it underneath the question over here. 1 yard per 3 feet. Notice that's not square yards. So we have to change our conversion factor into squares. And we're going to make that squared. So we're going to say 1 yard squared is equal to, or per 3 feet squared. Now I've squared both. Now let's do the math. We have 360 feet squared over 1. We're going to multiply that by the conversion factor to get it into yards. So we're going to have 1 yard squared over, well, I forgot to square my 3, so this is actually 9 feet squared over 9 feet squared. Do the math. So feet squared and feet squared cancel. 360 divided by 9 is going to be 40. And our units are yard squared. So how many square yards of carpet does she need? 40 yards squared, which is answer choice G. Now, I almost forgot to square my 3 because I got in a hurry. So be very careful when you're working through these math questions. If it happens to me, it can happen to you. And a lot of these questions, find out these little tiny errors, if you will, really undermine young adults. So I'm glad this happened because it made me think about bringing this point out to you. When you take the test for real, and you know it's going to be put on an actual transcript, on test day, you may go through all these questions and finding answers, but had I not caught myself and squared my 3 here, I would have calculated an answer that would have been incorrect. So be very, very careful on test day. Now, guys, with that being said, I'm ending it here. I'm trying to keep these short and sweet so it doesn't waste a lot of your time. If I can ever be of any help to you, our contact information is below, and you can always send me an email, contact me, and I'll reply. Please remember, my purpose is to try to reach individuals that are that don't have a means to get any help. And please like the video, share it, and subscribe to the channel so we can reach those individuals who may need us. Okay, thanks for everything. Hope you enjoyed it. And you guys have a great day.